DE 24/7 podcast. I'm here today with Dimitrios Siskos, Chief Technology Officer at Beta CAE. Welcome to the program, Dimitrios.
Thank you, Brian.
Can you tell us a little bit about yourself and the company before we get started?
Sure. My name is Dimitrios Siskos, and I serve as Chief Technology Officer in Beta CAE Systems. Brian, I would like to thank you for giving me the opportunity to talk about our solutions. Now, some things about me. I have a PhD in mechanical engineering. I started working for Beta around 2000 as a software developer. At this time, I started working on a new finite element post-processor that eventually became Meta, the post-processor of Beta CAE Systems. Maybe you already know that Beta CAE started from a group of engineers. As a company, we love engineering and we love helping our fellow engineers to solve complex simulation problems. Currently, as a CTO, I'm responsible for all Beta CAE developments, and of course, you can check out everything about Beta CAE in our website.
Well, speaking of engineering challenges, recent events have made it very difficult for a lot of companies because they're doing work from home or they have to do remote collaboration. So it's even more important now than it has been before. How are augmented and virtual reality technologies playing a role in helping engineers collaborate in these kind of circumstances?
Brian, to tell you the truth, we've been working on the remote collaboration area even before the pandemic. So we have a new product called NIRI, which is a web-based platform enabling collaboration between multiple users in desktop and in VR at the same time. And this product was released at the beginning of this year. So this February we were ready and showcased NIRI and VR collaboration in our 3 India Beta CAE events with great success. More than 600 people experienced NIRI and VR and how it feels to work together with a colleague on the same virtual environment. Now, recent travel restrictions forced companies to look for alternative ways to work together as one team. With NIRI and VR, you can travel virtually, be together in the same virtual environment, inspect the same virtual model, review design proposals and simulation results, in general interact and exchange ideas. This gives the feeling that you are physically collaborating as you would normally do in reality in the same room with your colleagues. We have developed many functionality, for example, personalized avatars that further promote this feeling of that you are sitting with your colleague together, and also the ability to see your colleague actual face mapped in the avatar. And believe it or not, this makes a big difference in the engagement.
Kind of along that line, since we're still in the early phases of adoption of this technology, for companies that are looking at utilizing AR and VR, what are some things they might need to know or some advice you could offer on making this work well for them or on getting started?
My advice is in general to be open to new ideas, to actually experience VR and AR before deciding that this is not for your company. To tell you the truth, I was also skeptical when we started our development in this area. I told you that we are an engineering company and we love tough engineering and simulation problems. Now VR and how this come together. All my concerns were addressed after wearing the first time the head-mounted display and started navigating and interacting naturally with the 3D model in 3D space. VR 3D navigation is much faster than mouse and keyboard navigation and also much more engaging. Our CFD colleagues stay inside VR for hours, generating streamlines, interactively editing cut planes, viewing vortex cores, and all these fancy things that CFD engineers want. As I see it, VR is like a new 3D mouse, and the audio and the speech recognition and voice commands that we have implemented can become a new way to write as you do with the keyboard. These days, I see that more and more companies are started to think about VR and remote collaboration and how to use these technologies for improving their decision-making processes. If you check out our recent events, you will see presentations of big automotive OEMs and other manufacturers that use our VR and ERI technology. Another advice is that we want to hear from the customers, their ideas, their problems. We often sit together with the customers, analyzing their ideas and their concerns, and we develop together a solution. So, in one sentence, my advice is share your concerns with us, and we will try to do our best to address them.
As you mentioned earlier, the company has a lot of products and solutions for remote engineering collaboration. Can you give some examples or talk a little bit in more detail about how the AR and VR element can enhance that type of collaboration?
How this collaboration works. Niri, which is the front end, is the first step for the collaboration. It's a web platform, as I said before. This that everyone can operate in order to start collaboration between colleagues and clients or suppliers. Now, our main engineering tools, Hansa and Meta, connect to Niri, and collaboration is handled by our collaboration server that broadcasts commands to the connected clients. This way, we also guarantee security of confidential modeling data. Our clients have very strict rules about confidential, about their data, and they want to protect this. But with our technology, model information is not transmitted. Only commands are transmitted. The data remains safe in the local network of each participant. The same is happening when VR users are also participating in the collaboration. The difference here is that, as I said before, the feeling of being there physically. You can see each other and hear them talk as you would if you were in the same room together. This is not an easy task for us to achieve. For this reason, we developed a 3D spatial stereo sound engine for that to happen, so that you can understand where a speaking colleague actually is in the virtual room without looking around. But this pays off. As I said before, in our Indian events, a client told me that it feels like I saw my colleagues during that meeting, even if the meeting was virtual. With this command passing technology, we're able to support our clients that have multiple sites all over the world. For example, we have multiple customers collaborating between Europe and Asia. Coming to how VR can enhance collaboration. You can do things that are very difficult to do in the standard desktop computer and also, of course, in real life. For example, you can get by just moving your head inside a small pipe to see how the fluid flows in this pipe, or make a cut and identify a problem inside a solid structure, or disassemble parts after a crash simulation to look for internal cracks and unwanted deformations. And this is done very naturally. This is the difference with the desktop. You just move your head and you are inside the model. You don't need to fix the view with your mouse. VR help us also to imagine new ways of collaborating, a new way of interacting with the product under development. This way we start building a common understanding of the product, and that we are building as a team. Both designers and engineers sit together, physical test engineers and simulation engineers, and also decision makers. I can give more examples. For example, we have released many tools in VR in the recent years: an interactive crash simulation post-processing experience, a CT scan of a physical component in VR for comparing with a virtual model to check for manufacturing defects, for example, a connection inspection functionality to see if all the connections are applied correctly, a tool for sculpting the mesh and modifying and smoothing the mesh of models coming from topology optimization. The applications are many. This December, we plan to release also morphing collaboration in VR, which is also very interesting, I think, for teams that work remotely and want to collaborate about checking new design proposals. AR also is in our plans. For example, we want to create an augmented reality tool for helping physical test engineers, for example, to place strain gauges in the physical model by overlaying the 3D model to guide them where to put these strain gauges.
Well, kind of along that line, then, with all those type of capabilities available, what are some of the challenges you think companies might face if they're trying to incorporate the technology, and how can you help them overcome those challenges so you can successfully use them, in those types of applications?
At the beginning, all of the challenges were IT related. We had many network restrictions to bypass, for example. I talked about intercontinental collaboration, and you can imagine how the bandwidth and latency of this network is unpredictable, let's say. For this reason, we developed special algorithms that monitor the network status and adapt the rate of our command passing mechanism. Also, we had to do a lot in order to secure everything in this collaboration environment that we are building without leaving any concern to our clients about data compromises. Another concern was the hardware performance and, of course, the performance of our tools, the algorithms that we use for graphics visualization. Organizations need to buy VR-capable GPUs, and of course, the head-mounted displays. This is not a big cost these days, but many companies don't have recent GPUs. This is a requirement. On our part, we tried very hard to optimize our graphics kernel in order to be able to handle huge simulation models that our customers analyze every day. Another concern is how to collaborate, for example, in different time zones. For this reason, we developed tools that allow users to record and share a collaboration session in VR and in desktop with other colleagues that are offline due to time zone differences or for another reason. So they can replay this collaboration session. To conclude, I will say that for me the biggest benefit of this technology that we developed is that enables collaboration of different mindsets in product development. Our technology allows various domain experts from design teams and simulation teams, physical testing and manufacturing engineers to come together and interact with a product. They can communicate their ideas much better. This is something that it's coming from our clients. They told to us this every time. With the VR, the feedback and the collaboration between these different mindsets is greatly improved.
All right. Well, thank you very much for your time, Demetrios. Thanks for being on the program.
Thank you, Brian.